Alright class, this is section 2.4, measures of central tendency. So in this example, what I want to do is look and find the mean and the median, more particularly dealing with rules of rounding, and check out my other video that I did on rules of rounding and where to find that, and a little update for the class right now. And the other issue here, so the rules of rounding and also how to find the median for an odd list of numbers, and that's what we're kind of looking at, those kind of the two themes with that. So let me get to the problem here without spending a lot of time through it. And then as I do, if I can, go to the videos and update, put timestamps on things in the description on YouTube. That'll probably save you time here. So if you want to skip ahead this video and go to the example that I did on the median instead of the mean, you could do that, cut to the chase. That would probably save you time trying to study for the class. It says here, and let me read this here. It says the following data shows the number of months patients typically wait on a transplant before getting surgery. The data from smallest to largest is ordered. Calculate the mean and the median. So I've already kind of outlined this a little bit and talking about this rules around here. So here is all the data, and just to point out that our sample size is indeed 39. So we have, in other words, we have an odd list, and so the symbol, I guess the international symbol for sample size is the lowercase n, so it translates to that. As I go through and find the stats, we need to keep in mind these rules of rounding. So because we have whole numbers, I want to round that to one more place than a whole number. Check out my rules of rounding, more particularly that that first sentence there I have on that, and that could be found under resources and modules there on our Canvas page. Alright, so starting off with the first one here for the mean, I'm going to start here with the X bar, and I like to think that that's just a sample of 39, those, and how many months they had to wait to get the transplant, so rather than everybody in the world. Well, of course, to find the mean, by definition, you add them up and divide by the number of values. Again, divide by the sample size, and here that the sum, if you add those all up, you get 544. So I want to take that total and divide that by 39. But another thing here to point out, and let me go ahead and highlight some other values here, is that there are repeat numbers. And so this would be typical. Like, let's say, here we've got those 4 7s, 2 8s, 2 9s, and it looks like we have 5 10s in there. So I could put this all in table format, like I did another example here, finding the mean for ungrouped, for an ungrouped frequency distribution. This could be done the same way as that one. So with that, you can do it either way. I can find the mean with a frequency distribution, more specifically ungrouped, because I would tell the frequency for each whole number. I would say here that we have 1 3, 1 4, 1 5, 4 7s, 2 8s, 2 9s, 5 10s, etc. as I describe that table. And then I would go through the steps, multiply, add, and divide to find the mean. That's no different than what I would do here. That if you just take the total, add them all up, and divide by the sample size, it gets you the same answer. And so I kind of wanted to point out here, in discussing those rules of rounding, that if you take 544 divided by 39, you're going to get this repeating decimal. We don't want that. And usually this is the question, even if we get anything to the right decimal, usually the question is, well, do I even round it? And so in a case like this, you definitely want to, because you can't write down that whole number. So I want to round to one more place than a whole number, that meaning here the nearest tens place, but you just can't just cut it off at the tens place. You have to round at the tens place, and that's why I want to focus here, not on just the 9, but the number to the right of the 9. That's going to help me round that number 9 there. And so here, to the normal rules of rounding, if the number to the right of that you're trying to round is 0 through 4, you keep it the same. But if it's 5, 6, 7, or 9, you want to obviously increase the number that you're rounding, not the 4 here, but the number that you're rounding up by 1. So because that number is a 4, we won't need to add 1, so I have a little mistake here. Basically, think of it like this. I want to add like 0 to it. In other words, keep it the same. So But if the number to the right of the 9 is 5, 6, 7, 8, or 9, I want to add 1 to that. So again here I've got a little bit of error, so I apologize. I think I got sidetracked thinking, but the answer should be, because that's a 4 to the right of the 9, this makes this 13.9 months for the solution. What you don't want to do is get caught up like in some like rounding and rounding. So I realized that even if you go to the right of the 4, the 8 maxes out of the 5. Well, you think, well, that becomes a 5, then this will become a 10. It doesn't work like that. So we basically ignore everything else except for just the one number to the right of the number that we're trying to round. I want to round to the nearest tenth, one number to the right. It's a 4, we keep it the same, and that's why we have 13.9 months there. So that is using the rules of rounding to find the mean for part A. Now we're going to go ahead and skip down here to part B, finding the median. And of course here the most important is to put those in order. On the exam I'm going to have those out of order, but it's not going to be an outrageous number of numbers in order to be able to sort. But more importantly here, if I kind of zoom in on this, is that the sample sizes are 39, and I want to divide that by 2. So if you take 39 divided by 2, you get, kind of think like if it was 40, 40 divided by 2 is 20. This is going to be 19.5. And when we get to 2.6, we're going to call that the letter L for location. And you can't find the 19.5 location. So what we're basically going to do is kind of cut off everything else off that decimal. I want to count the 19th number. So don't round. This is not normal rules of rounding. I just want to concentrate on that number. Just think of it as an algorithm. These are just made up steps that we do in order to achieve this answer. And it seems a little loosey-goosey here, but I'll get into more detail when I get to 2.6 on that. That'll make more sense then. So if you get a 0.5, and if you divide any odd number by 2, you're going to get a 0.5. Just cut off the 0.5, and you're going to work with that 19. So coming back up to the list, I want to find that 19th, or count the 19th number. Our answer is not going to be the 19th number, however, the one after it. I'll show out why. So we got 3 here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Great. So this second 12 is the 19th value. So we have 19 values below. Below what? The median. If I zoom in on that 13, which I need to, if you have an odd sample size, then the median is directly the one in the middle. If you had an even sample size, then we're going to have to take the middle two values and divide that, average them together, add them together, divide by 2. Here we don't have to do that. And the reason why that points out there, let me look at the rest of this list, that there's going to be also 19 values above, not including 19 values above the median. If we go ahead and count that, you'll see that that's the case. That's why that puts 13, the median, in the very center. Okay. Let me go ahead and go back to counting again. So we got 14. Don't start off with a 13. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So there it is, proof that there are 19 values below the median and also 19 values above it. Okay, that will be, I guess, my math in that way, showing my work that way to figure out to find the median of the list. So nonetheless here, that the median is the number 13. And kind of comparing these two together, we're saying that the mean could be 13 or is 13.9 months, almost 14 months, but the median would be 13. Those are relatively two close numbers to one another. Probably indicates that we don't have any outliers here in this case here. So everything seems to be closely clumped together. If those two numbers really disagree with one another, and I explained this in another video talking about outliers, outliers affect the mean, variance, and standard deviation. They're definitely going to throw those off. And in fact, you'll have probably a homework problem related to that idea too, about what measures of anything, what statistics, or sorry, what kind of data throws off your stats. And of course, the end-all story is your outliers. So not to say that we want to get rid of outliers, it's just notice that it will affect things and that you may want to try to compensate that with a different level of measure. So anyway, this will do it here for an odd sample size, finding the mean and the median.